Imagine traveling to the farthest edge of our solar system, far beyond the familiar planets, beyond the icy dwarf worlds, and into a region almost completely unknown. Here lies one of the most mysterious frontiers of our cosmic neighborhood, the Oort Cloud. This distant region marks the hidden boundary of our solar system, a place where the sun's influence slowly fades and the vast darkness of interstellar space begins.
Beyond Pluto, and even beyond the Kuiper Belt, lies a mysterious region that surrounds our entire solar system. Astronomers call this distant frontier the Oort Cloud. It exists at the extreme edge of the sun's gravitational domain, a vast and distant halo of icy objects drifting silently in the darkness. Here, our solar system meets the enormous emptiness between the stars.
The scale of the Oort Cloud is almost impossible to imagine. Scientists estimate it may begin around 2,000 astronomical units from the Sun, and from there, it could stretch outward to nearly 100,000 astronomical units, almost a full light year into space. To put that into perspective, 1 astronomical unit is the distance between Earth and the Sun, about 93 million miles, or 150 million kilometers. The Oort Cloud begins thousands of times farther away than that.
The Oort Cloud is believed to contain billions, possibly even trillions of icy objects. These frozen bodies are ancient leftovers from the birth of our solar system. Together, they form a giant spherical shell surrounding the Sun. Many of the long-period comets that occasionally visit the inner solar system are thought to originate from this distant reservoir of ice. Scientists believe the Oort Cloud formed billions of years ago during the chaotic early days of our solar system. At that time, powerful gravitational forces from giant planets like Jupiter and Saturn scattered icy debris outward into deep space. Over millions of years, this material spread out and formed a vast spherical cloud, held loosely by the sun's weak gravitational pull at incredible distances. Occasionally, something disturbs one of these distant icy objects. A passing star or a subtle gravitational interaction nudges it from its quiet orbit. Slowly, it begins falling inward towards the sun. This journey can take thousands of years. But when the comet finally reaches the inner solar system, the sun's heat creates the brilliant glowing tail we see from Earth. Giant spherical shell, 249 through 317. Unlike the planets, which orbit the sun in a relatively flat disk, the Oort Cloud is very different. It forms a massive spherical shell surrounding the entire solar system in every direction. This three-dimensional structure suggests that long ago, gravitational interactions scattered icy material outward in all directions. The Oort Cloud may represent the outer boundary of the sun's influence. At these enormous distances, the solar wind weakens and gradually gives way to the interstellar medium. Beyond this region, the sun's gravity becomes too weak to tightly hold on to distant objects. This is where our solar system begins to merge with the wider galaxy. Despite its enormous size, the Oort Cloud has never been directly observed. No spacecraft has ever traveled that far. Even Voyager 1, the most distant spacecraft ever launched by humanity, will not reach the Oort Cloud for another 300 years. Much of what we know about it comes from scientific models and the behavior of distant comets. Beyond the Oort Cloud lies something even more extraordinary: interstellar space. This is the vast region between the stars, where the sun's influence fades completely and the domain of other stars begins. The Oort Cloud therefore marks the true gateway between our solar system and the immense galaxy beyond.